Hello everyone, in this video we're going to explore the triangle congruence by ASA and AAS theorems. Alright, first we will talk about the ASA postulate. If triangle ABC and triangle DEF have the angle A congruent to angle D, the side AC congruent to DF, and angle C congruent to angle F, and then triangle ABC congruent to DEF by ASA theorem, right? Because one side right here is between two angles, right? Now, ASA congruent requires the congruence of two angles and the side between those angles, right? Now we're going to move on to the second one, AAS theorem. If triangle ABC and triangle DEF have angle A congruent to angle D, side AC congruent to DF, and angle B congruent to angle F, then triangle ABC congruent to DEF by AAS theorem. In this situation, the side doesn't have to be between two angles, right? Look at this one right here, right? This guy actually the special case of ASA theorem. Why? We can use the Triangle Sum Theorem, right, to prove that angle C right here congruent to angle F, right? Since this guy congruent to this guy congruent to this guy, right? By Triangle Sum Theorem, this guy at this guy equals 180 degrees. This guy at this guy equals 180 degrees. But this guy congruent to this guy congruent to this guy, then this guy must be congruent to this guy by transitive property, right? So then AAS actually ASA, right? Now AAS congruence requires the congruence of two angles and a side which is not between those angles. Now let's move on to example number 1. We're gonna prove triangle congruent using ASA theorem, right? Which two triangles are congruent by ASA, right? So look at this one right here. We see that angle U congruent to angle E, right? Side length UV congruent to side length OE. Angle V congruent to angle O. Then the triangle SUV congruent to NEO. Now look at this guy right here. We don't have any triangles that's congruent to this guy, right? Now let's move on to example number 2. Write proof using ASA flowchart. Alright, given angle A congruent to angle D, side length AB congruent to side length DE, angle B congruent to angle E. Then we need to prove triangle ABC congruent to triangle DEF. Alright, we need to use the flowchart, right? So we're gonna start right here. This is 90 degrees, this is 90 degrees, right? So we need to say the measure of angle B equals 90 degrees. Measure of angle E equals 90 degrees. Then the angle B congruent to angle E by definition of right angles, right? Next one, angle A congruent to angle D given, right? And side length AB congruent to side length DE is given, right? It's right here. Then triangle ABC congruent to triangle DEF by ASA, right? Now example number 3, we're gonna prove the AAS theorem, right? So given angle A congruent to angle D right here, angle B congruent to angle E, side length AC congruent to side length DF, we need to prove triangle ABC congruent to triangle DAF. Now we're going to use ASA theorem to prove this theorem, right? We're going to start with the triangle sum theorem. So in triangle ABC, we have angle A plus angle B plus angle C equals 180 degrees, right? Then angle C equals 180 degrees, subtract angle A and angle B, right? Similarly, angle F right here equals 180 degrees, subtract angle D and angle E, right? But angle A congruent to angle D, angle B congruent to angle E, right? So by transitive property, you can conclude that angle C congruent to angle F, right? After you prove that angle C congruent to angle F, then you can say AC congruent to DF given, right? Angle A congruent to angle D given, right? So triangle ABC congruent to triangle DEF by ASA theorem. And this finishes the proof, right? From now on, if you given AAS, you can apply this theorem directly. You don't need to prove this theorem again. So technically, AAS and ASA, they're both the same, right? Example number 4, we're gonna write a proof using AAS theorem, right? So given angle M congruent to angle K right here, right? Now W and parallel to RK. We don't know if they congruent, right? So don't assume that they congruent. Now we need to prove that triangle W and R congruent to RKW, right? Which is the upper triangle right here congruent to the lower triangle right here. Now we always start with the given thing, right? So we're gonna copy this one down over here, right? Now since WM parallel to RK right here, we can conclude that angle MWR right here congruent to KRW is going to be right here by alternate interior angle theorem, right? Now observe that these two triangles share the same side length WR. Then we have WR congruent to itself by reflexive property, right? So then triangle MWR congruent to KRW by AAS theorem, right? Look at this diagram right here. We have A right here, right? The first angle, the second angle right here, right? And the side lengths right here, right? A, and S, right? Example number 5. Determine whether triangles are congruent. So we look at the diagram right here. We have angle B congruent to angle U, right? Angle I congruent to angle T, right? So we need to determine if this triangle congruent by AAS or ASA, right? So we look at this guy right here. We see that angle. We need the side length in the middle right here to use ASA, right? But it's not given, right? So we eliminate this guy, right? So we're gonna eliminate A right here, right? Because it says ASA. Now, if we use the side length right here, right? This guy right here and this guy right here must be corresponding, right? But this guy and this guy not congruent, right? However, this guy and this guy congruent, right? So we cannot conclude that this triangle congruent by AAS, right? So the answer must be B, right? FB and OT are not corresponding side. Look, this guy and this guy not corresponding side, right? This guy and this guy are corresponding side, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. She puts her hand